Hello students. So in the last lecture what we have seen? So in the last lecture we have seen the theories based on this dam. So in last lecture we have seen the theories based on this dam, and today we are going to start the example based on this dam. So let's start with first example. Just a minute. Okay, so let's start with this first example, that is so the first example, that is a concrete dam of trapezoidal section has a top width 2 meter, bottom width given as 6 meter, and the height of dam that is given as 12 meter. It retains the water up to the 10 meter vertical sides. Now we have to determine the maximum and minimum stress intensity at this base of this section. The density of material that is given to us, that is 24 kilonewton per meter cube, and the density of water that is none to us, but also it is given in example that we have to use 10 kilonewton per meter cube. If it is not given, then if it is not given, then you can use as 9.81 kilonewton per meter cube. If it is not given, then and then you have to use this value. Okay, so let's move forward. So let's to solve this example, we have to first make the figure based on this given data. So let's do it. So here in this example, the top width that is given to us, that is 2 meter. So the top width in the dam that is given here as a 2 meter. Okay, so now let's, the bottom width that is given to us here, that is 6 meter. So here the bottom width is 6 meter. So in the figure the bottom width we have drawn, that is 6 meter. Now the third data that is given, the height of dam. So the height of dam in this example that is given here is 12 meter. So in the figure the total height, the total height of dam that is given us as a 12 meter. So next it retains the water up to the 10 meter. So height of water that is given in this example, that is 10 meter. So here in the figure we have drawn the water height up to this level, the water is present. So this height that is given as a 10 meter. So the figure of this dam is completed. Now based on this figure, in the last lecture we have seen how to compute the forces that acting on the dam. By using that concept, we have to draw the stress distribution diagram in the dam, and we have to find the first forces that acting on the dam. So for that purpose, as we all know, on water side the water pressure is acting, horizontal water pressure is acting, and its distribution is triangular one that we have seen in previous lecture. So the intensity of this water pressure at the base, that is what? Gamma into HW. HW over here is what? So here HW is the height of water, that is 12 meter. So in this example HW that we have to put as a 12 meter. And what is gamma? That is the density of water. So in this example gamma, that is density of water, that we have to put as a 10 kilonewton per meter cube. Okay, so by using this we can easily find this gamma into HW. So that we can find out. Now we have find out this gamma HW. Now we have to compute this total pressure PW, and this PW is how we can compute? By using this area of this triangle. So what happened? Let's see. PW. So PW is equal to area of triangle. So what is PW? That is the area of that triangle. So we have to take this area of that triangle. So it will be equal to 1 by 2 base. What is base? That is gamma HW. So gamma HW, gamma, that will be equal to 10, HW that will be equal to 12. We have to put. So gamma into HW. So directly I am putting, that is 10 into HW, that is 12. That is base into height, height that is 12. So it will becomes look like that. So do it in let's do it in calculator. That is so we'll do this computation at the end. So by using this we can find out this PW, and this PW is acting at which height? So this PW is acting at, so like this PW is acting at a height h by 3, or if it is this height is HW, then it will becomes HW by 3. So HW is 12, then it will acting at a height 4 meter. So it will be acting at 4 meter from the base. So it will be acting at a 4 meter from the base. So likewise this we can compute this pressure. So here the pressure is computed. It will becomes what? The height is given to us, that is water height is given to us 10 meter. So here there is one mistake. The water height that is given to us, that is not 12, it is 10 meter. So sorry, I can correct it. So the HW, that is the 10 meter. So the PW will becomes 1 by 2, gamma is 10 into HW, that is 10. Okay. And the height, it will becomes base, that is gamma HW, and the height, that is again 10. So this total pressure will becomes 10 into 10 square divided by 2. So here it is given 10 into 10 square divided by 2. It will come out as a 500 kilo Newton. Okay. So we have find out this water pressure. So water pressure we have find out. Now second, that we need to compute the self weight of the dam. So for that self weight, we have seen in previous example that the weight of dam will be equal to nothing but the area multiply it with the density. So the area, so here it is a trapezoidal section, so the area will be equal to the top width plus bottom width divided by 2 into height. So the top width is A, this is area, and this is density. So top width is 2, bottom width is 6. So here the top width A, that is A, sorry, that is top width, so it is 2 meter. B, that is bottom width, so it is 6 meter, and H, that is the height of dam, so it is 12 meter. So we have to put these three data in this, AS2, BS6 and HS12, and the density gamma D. So here in the question, the density of dam material, that is given as 24 kilonewton per meter cube, that is the gamma W. So this value is the rho D, density of the dam material. Okay, so by putting this we can easily find out the weight of the dam, that is coming out as 1152 kilonewton. Next we have find out the water pressure, that is coming out as 500 kilonewton. Okay, now this water pressure that we know, it is acting at a HW by 3 height, but we have to find out the Z value that we have seen in previous theory, how to compute this Z. So Z will be equal to, these are the formula that we have derived in last session. So Z will be equal to x bar plus H into PW divided by 3W. So all the data we have us with H, we have a PW, we have a W. Now we need to find this x bar only. So we have to compute this x bar. So by x bar, that will be nothing but x bar will be equal to CG of trapezoidal section. So for that, whatever the formula that we have derived or we have know in very well during this show, we know the equation for this CG, how to find the CG of the trapezoidal section. We know the equations. By putting the data in that equation, we can easily find the CG of this trapezoidal section. By putting this data, Z we can easily find, and Z is coming as 3.91 meter. So now what we have done, we have find out this Z. Now we know the equation for the eccentricity. So eccentricity will be what? That will be equal to Z minus B by 2. The Z is coming as 3.91 meter, and B, that is total base width, that is given to a 6 meter divided by 2. So it will becomes 0.91 meter. Here it is coming as 0.91 meter. So now go next. Based now we know the equation for this maximum stress, that is W by B 1 plus 6A by B. We have derived in the very first lecture of this chapter, that is direct and bending stress. We have to put W, that we have already known. Eccentricity we have found out. Base width we know. So just we have to put the data and we can compute this maximum stress. Also by putting this data in minimum stress equation, we can get the value of this minimum stress. Now the thing is that at which point this maximum stress is acting and at which point this minimum stress is acting, that is the important thing to know. So how to represent it in figure, that we are going to see. So here this is the dam, the water pressure is acting on this side. here uh, so let's make it. So the water is acting on this side. Here on this side the water is acting. It is full of water. It is, we can say, it is the reservoir for the dam. Okay, so here on this side the water is acting, and let's say do it as black. It is a dam. So this is the dam body. It is dam. So here it is dam. It is so here it is dam body, and it is reservoir. So here in this dam the water side is known as a hill for the dam, and so let's do it like that. Just a minute. So this point so this point is known as a hill for the dam, and this point is known as a toe for the dam. So this point is known as a toe for dam. So now the maximum pressure is acting at which point, hill or toe, that we need to know. So what happens generally, this water pressure is acting, as we know this water pressure PW, this acting at this, and it try to overturn this dam about this point that is known as a toe. So this toe, so this water pressure try to overturn this dam about this toe. So what happen, the maximum pressure will be generated at that toe point. So here it is a sigma maximum, and here it is sigma minimum. So now it is clear how to draw this pressure distribution diagram in dam. Okay, so likewise this we can draw these combined stresses. So students, very most frequently asked example from this dam, that portion, that is this we have to calculate this combined stresses and draw the diagram for this. So what we have done, that see here in this example, top width, bottom width, height of water, and densities of material and water that are given, and we have to compute the stresses from these two data. So we have to first compute the forces that acting over this dam. Major two forces that we have to compute, that is the weight of dam and the water pressure. By using these two, and eccentricity calculation is done. Based on this eccentricity calculation, by putting the maximum and minimum stress, we can find out this maximum and minimum combined stresses, and likewise this we can draw this distribution diagram. So here this example is finished. In subsequent lecture, next lecture, we are going to do the next example based on this dam. So here this example is done. In next lecture we are going to do solve one more example based on this dam, and then we will move for retaining wall and the chimney, and we will complete this chapter, that is direct and bending stress. Thank you everyone.